Sometimes we want to solve more than one equation together at the same time. There are several ways of doing this. In this section, 5.1, we'll look at just one way. And this probably is a review, but the idea is that we're going to use elimination, which means we're going to make something cancel out. So the equations have to be in standard form. That means the numbers and letters on the same side equals, so something x plus something y equals a number. And then we're going to choose a letter to cancel out. And then we're going to multiply both sides to get opposite numbers in front of that letter. So opposite numbers means the same number but different signs. So like 4 and -4, or 8 and -8. Those are opposite numbers. Then we'll add those two equations together, and we'll get a new equation that only has one letter in it. And we'll solve for that letter, and then we'll put that back in one of the original equations, it doesn't matter which, to find the other letter, and then we'll write our answer as a point, or sometimes the directions will say ordered pair, and that means parenthesis x, comma, y. The x always comes first because it comes first in the alphabet. If it had two different letters, you put the letter that comes first in the alphabet first in the parentheses. So let's look at what all that means. On your page, those have a bracket in front of them, and that shows us that it's solving those two equations together at the same time. So we want to make one of our letters cancel out. And what I see when I'm looking at this is that here y is negative and here y is positive, and having opposite signs will help us. So if I want to make my y's cancel out, I need to have the numbers in front of y's be opposite numbers. So one needs to be positive, one needs to be negative, but they need to be the same number. Well, I can use 4 because the bottom equation already has a 4, but I need to put a 4 in front of the y on the top equation. In order to do that, I multiply the whole top equation by 4. So that means everything. So I'll take 4 times 2x, and I'll get 8x. 4 times negative y, so that gives me negative 4y. And 4 times 9 gives me 36. Now this bottom equation I'm just going to copy because it already has a 4 in front of the y. So I have 3x plus 4y equals negative 14. And then I'll add those two equations together. So here's where things are going to cancel out. So I have 8x plus 3x is 11x. Negative 4y plus 4y cancels out, equals, and 36 plus a negative 14 is 22. So this is what I was trying to say before, is that now we've got an equation with just a single variable in it. We'll just divide both sides by 11, and that gave me x is equal to 2. So now I know what x is. So I go back to either one of my beginning equations. It doesn't matter whichever one looks shorter and easier. To me, the one on top looks a little bit shorter or easier, smaller numbers. So I'm going to put this 2 in place of x in that top equation. So I just put it right here where the x was in parentheses. So I'll start by multiplying those together. So I get 4 minus y equals 9. I'll subtract 4 from both sides. So I get negative y, don't lose the negative in front of the y, equals 5. And then you either need to think about it as dividing. Sometimes people like to divide by -1. I like to just think about moving that negative sign to the other side. Either way, you should end up with y equals -5. And then we need to write our answer as an ordered pair. So I write the x first, and then the y. So 2, -5. So this tells me what this means is that if I replace x with 2 in the beginning problems and y with -5 in the beginning problems, it makes both equations true at the same time. Okay, it's a solution that works not just in the top one but also in the bottom one. Let's try another one. So again, these should be hooked together to tell us that we're solving them together. And I look at this problem and I want to say, okay, I need to get rid of a letter. So it doesn't matter in this case whether I choose X's or Y's, because here I have a positive and here I have a negative, or here I have negative, here I have a positive. So either way, no matter what you do, you can choose X or Y, it's going to be fine. We'll just do X to do something different this time. So if I want my numbers in front of X to match, then I want to shoot for a 12 in front of that X. So I'll multiply that top equation by 3. So that means, again, everything in that top equation. So 4 times 3 is 12x. And then 3 times 3 is negative 9y. And then 3 times 25 is 75. Now in this bottom equation, in order to get a 12 in front of the x, I'd want to multiply by a 4. So that gives me negative 12x plus 24, no, times 4. 8 times 4 is 32. 32y. And then 10 times 4 is 40. So now I'll add those two equations together. You'll always add the equations together. So that's going to cancel out. Negative 9 plus 32 is 23. And 75 plus 40 is 115. I'll divide both sides by 23. And I'll end up with y equals 5. So now I go back to either one of my beginning two equations. It doesn't matter whichever one looks like it has smaller numbers. So we can use the top one again, or if you want to use the bottom one, that's fine. You'll get the same answer either way. I'm going to put this in place of 5 in that equation. So we'll simplify that. We'll do this multiplication. So I get 4x minus 15 equals 25. And then I need to add 15 to both sides. So I get 40. I'll divide both sides by 4. So I get x is equal to 10. So I'm going to write my answer as an ordered pair, x first. So I get 10, and then y, 5. And again, to check it, you could stick that 10 in place of x and the 5 in place of y. In the top equation, you should get 25. In the bottom equation, you should get 10. So we'll look at a couple more. So we'll do this one together. So in this problem, again, we could either choose x or y. It doesn't matter which. My x numbers are maybe a little bit smaller, so maybe I look at the 4 and the negative 3. And also we just did that so that we know that we could multiply the top equation by 3 to get the 12 in front of the x, and the bottom equation by 4 to get the 12 in front of the x there. They already have 1 plus, 1 minus, so they're already opposite signs. So if we multiply everything in the top equation by 3, I get 12x minus 24y equals 75. If I do the bottom equation by 4, I get negative 12x plus 24y equals 40. So I'm going to add these together. And you can see this cancels out and this cancels out. If everything cancels out, we're left with 0 equals 115. Well, 0 can't equal 115, so this is no solution. Again, in the language of our beginning section, this means this is inconsistent. There is not an x and a y that makes both of those equations true at the same time. One more. So again, we've got these two equations that we're trying to solve at the same time. And you can see on the bottom equation that it says x equals. Well, that's not the right format. We need this negative 3y to be on the other side. So we're going to add 3y to both sides to take care of that. So that gives us x plus 3y equals 16. Top equation is still x minus 2y equals negative 9. So now that they're in the right format, we can work on them. Here's where we have opposite signs, so let's get rid of our y's. To do that, I'm going to multiply the top equation by 3 and the bottom equation by 2. You can always just use the opposite number, and that will help you cancel things out. So if I multiply the top equation by 3, I get 3x minus 6y equals negative 27. In the bottom equation, I would get 2x plus 6y equals 32. I'll add those together. The y's cancel out, so I have 5x equals, and negative 27 plus 32 is 5. So I divide both sides by 5, and I get x is equal to 1. So I take that 1 and I'd stick it back up into either one of these beginning equations. So I'll use the top one. So I'd have 1 minus 2y equals negative 9. Subtract 1 from both sides. So I get negative 2y is equal to negative 10. Divide both sides by negative 2. And I have y equals 5. Oops, let's write it as an ordered pair. X first and then y. So we get 1, 5.